Hello, everyone, and welcome back to .NET Conf. My name is Adrian Stevens, and my good friend and colleague, Jason. And what are we talking about today here?
Well, we're going to talk a little bit about Azure today. Today we've got Azure up, and actually, well, I say today, but really we've had quite a few sessions with everybody on .NET Conf today. So last up is our Azure discussion, and we're going to keep working with some of the tools that we've worked with through all of our .NET Conf sessions. But we're going to make sure that we have things processing in the cloud and working through the cloud now at this point.
Fantastic. And I've got my slides up here. We're going to go from edge to mobile with Azure. So we're going to go all the way from our IoT devices through a pretty impressive Azure pipeline.
Yeah, exactly. Processing pipeline on the cloud.
Yeah, impressive being what we can do in Azure.
Pretty amazing
and
stuff.
then consume it from a client application. And of course, we're from Xamarin University, so we're going to use a Xamarin client app to consume some data. So we've got a lot of cool things to show you, a lot of ground to cover.
Yeah, let's hear a little bit about you first.
Right, I guess. Introduce yourselves. Why are we here? My name is Adrian Stevens, and I'm the curriculum manager for Xamarin University. So I work with the team that writes the curriculum, the content, the educational training materials for Xamarin University. And of course, you are on the very talented training team.
That's right. I am one of the trainers, the live trainers at Xamarin University. And what we do is essentially exactly what Adrian and I are doing today, is we teach you guys Xamarin and Azure development in live classes. It's kind of even better in a way because right now I'm mostly talking at you. You have a little bit of ability to ask questions, but it's not quite as interactive as if you had your own mic, which is how our live classes are structured. We have 20, 30, 40 people in a class. Everyone's got their own mic. I tend to do most of the talking, but we have interactive sessions. We get questions asked, we talk to each other, we solve problems together, we work through building cool mobile apps, cool Azure apps.
But if I take a class with you, I can talk to you directly, I can ask you questions, I can get help.
Exactly.
Fantastic.
Work through the exercises, and we, of course, are coding and building applications during these classes. That's really key part of that experience, is actually building an application, seeing it working at the end of each class.
Absolutely, and we also have a free component. We have our self-guided learning at Xamarin University, so you can go on and take courses absolutely free.
Right, completely free.
Yeah.
Several hours, each class, I should say, is several hours of learning material.
Absolutely. So great intro content. Learn how to develop Xamarin.Forms applications, use Xamarin Android, Xamarin iOS, and again, you're going to be building real applications. And whether you do the free training or the instructor-led training, both of those will work you towards Xamarin certification.
Exactly, exactly.
Pretty fantastic. If you're interested, head on over to university.xamarin.com. We love Xamarin. I think you will as well.
We'd certainly love to see you there.
But you know what we also love?
Azure?
Absolutely. All right, so really the summary here is we're going to talk about a lot of cool things in Azure, and I think I might want to jump into the architecture.
And yet, as many cool things as we're going to talk about in Azure, it's worth pointing out that there's about 732,000 features in Azure.
Yeah.
So we're going to hit a small portion of them. Yeah. We're definitely not hitting all of them.
But what I love about this here is we're going to show you some great ways to use the services in Azure and give you an understanding of why we chose the ones that we did. And so to help you, this hopefully gives you a bit of insight and helps you navigate really the huge selection of amazing things you can do in Azure and make some sound decisions.
Yeah, absolutely.
So what are we doing? Well, I know Jason is a big fan of IoT. I am as well.
Absolutely. So anyone who watched our previous session knows how excited I get about IoT.
Absolutely. And so we wanted a way to really manage data from IoT devices and be able to process and consume that data on a client, on a mobile client.
Yeah, in fact, we have this one actually right here, this device right here, and we saw it actually going through the web, and we saw that we were actually able to completely reproduce an animation on the other side. And that implies a lot of data, right? The positioning data coming through many, many, many frames per second. That kind of data, that kind of throughput, we need special handling for.
Absolutely. Unfortunately, Azure has a great solution for us. And once we have the data in Azure, we might want some processing. We need to, whether we just store it, do some calculations. We'll look at a way to do that. I jumped ahead to storage. We're definitely going to store our data today.
Our data has to go somewhere, otherwise what's the point?
Yeah, absolutely. And then
it can go to another visualization, but
absolutely, yeah. There's lots of places it can go in Azure, but yeah, we're going to store it off.
But storing it is still a good idea.
And we're going to store it off really so we can have historical data and then expose that via a REST endpoint.
Right, and then that REST endpoint we could hit with a mobile app.
Absolutely.
We could, of course, hit that with just about anything, so maybe another website, but I think a Xamarin mobile app is a really great choice.
Absolutely. So if you see our diagram here, we're going to focus on the middle four there, the upper parts. Those are the parts that are in the cloud. But we'll talk a little bit about our edges as well there.
Yeah, and of course, the other sessions that we did during .NET Conf, we dove deep into both of those other two sides as well. So don't be shy about checking those sessions out as well.
Absolutely. And so we're going to start by sending some data, how we're going to send data really to the cloud. And to do that, we're going to use something called IoT Hub. So with that, from our architecture diagram, we're really focusing on the first part here. That's just the IoT device into Azure, into IoT Hub. So Jason, really, what is IoT Hub?
Well, IoT Hub is, as I said, it's kind of built to handle that extreme throughput that we're getting from IoT devices. In general, IoT devices are there to interact with the real world. As we kind of talked about in our last session, sometimes that means measurement. It often means measurement, sensors, getting data real time.
Right, reading the real world.
Right, reading the real world, and often many, many, many times per second. That's what we need to know to be able to reconstruct the information that maybe our machine learning algorithms or business analyst, BI algorithms are going to interpret.
Absolutely. And for us, we've been using a single device as example, but it's very possible. You've got IoT solutions that have dozens, hundreds, maybe even thousands of devices sending data.
Right. Quite frankly, I mean, if you're talking about a production application, it doesn't make much sense for me to develop a solution if I only have one device. It makes sense to develop a solution if I have hundreds of tractors out there,
exactly.
or thousands
Fleet
of devices.
tracking, I love equipment tracking.
Exactly, and quite frankly, that's how we get to the point of using machine learning algorithms to have that sensor data tracked and compared with the history of, say, a tractor breaking down, and we can see that based on the sensor readings we're getting from this thing, based on, say, how it's been moving or how it's been turning or something from the CO2 sensor, we think it's about to break down. Well, that's a lot of data. We need a lot of data coming in, and coming in fast. So there's special tracking we need for that. Further, or special ways to handle that much throughput.
All right, and this is where IoT Hub comes in. So it's purpose-built. I mean, the name says a lot. It's called IoT Hub, and it's meant to interact with IoT devices, and it's designed for these exact situations. But it's also designed with security in mind as well, where a lot of times these small devices aren't.
Right. We can't really put usernames and passwords in these things if they're headless, if there's no monitor, if there's no keyboard.
Right, and they might be out in the field, they might not be manned.
Right, it might not even really be a user, right? So like, as you say, it might be an unmanned device. And yet, if we're talking about a fleet solution, it's very likely that we're a big corporation with big corporate competitors. They'd love nothing more than to poison our BI data, the data that we're doing business intelligence against.
Right, so whether they're taking our data or sending false data. So we want to have some mechanism of security around that.
They'd love to get false data into our BI algorithms and machine learning algorithms. So we need some security wrapped around our device, wrapped around how we're getting our information to our cloud. And that is where IoT Hub comes in.
Perfect, and exactly. So IoT Hub, high volume, designed for IoT, and designed with security in mind. There's lots of great features. We'll touch upon a few of them. But what I want to talk about really is sending data to IoT Hub. And
right, now, of course, IoT Hub is also capable of getting data back to individual devices and fairly easily as well. But yeah, we're focusing on sending up.
Absolutely. IoT Hub, definitely two-way communication with those IoT devices. But yeah, so for sending data to the cloud, we're going to use a class called Device Client. And we'll be able to install onto our mobile client devices using the package, the APIs provided by the Azure team for IoT Hub.
Wonderful. Yeah, we have a NuGet package that we can just download into our .NET applications. If you're not a .NET developer, then you're probably not watching us right now because this is .NET Conf. But if you need to support a different platform, then there's a huge variety of platforms for which we have Azure client libraries available. But most of us are going to grab that NuGet package.
Absolutely. And so we're going to use that device client class. We're going to just create an instance, and really it comes right down to it. Send a message to IoT Hub. We're going to provide the appropriate data to that device client class, and then we're going to call send event async and fire up that string message.
Yeah, and the package is going to handle all the protocol negotiation, the retry stuff for us, the queuing up, failed messages, all that stuff's handled right there for us. We just say send async.
Let's look at just a little bit of code here and see how we can do this. So I'm going to open up a Visual Studio solution, and I've got a solution here with a number of devices, really. And by devices, I mean I've got applications meant to run on devices. And this is everything from a test console application, something meant to run on UWP IoT, or even Android things. And fortunately, of course, we're dealing with C# and .NET, and we love to share code. And so kind of the key code is actually in a shared project. So all of these applications have the API installed. They've got a NuGet package installed. And again, it's really great. So it's console, it's Android, it's UWP, and we've all got the Windows Azure, not the storage, but the Windows Azure client. So I can find this. Let's just search for Azure.
Yeah, just search for the exact.
Yes, a lot of packages going on here. Microsoft Azure Devices Client package.
There we go.
And so this is going to give us that the types we need to communicate with our IoT hub. And I'm going to jump. Well, let's just open up one of these first. I'll open my Android things here. And so we need a few pieces of information. I should maybe hide my keys, but I'll change those later.
Right.
But we're going to need a few pieces of information to send this data to IoT Hub. So I think maybe we should jump over to the portal and see where we get that information, and then come back to our code.
Let's look how we'll configure our IoT Hub in the first place, and then how we can get those keys necessary to authenticate that device.
Absolutely. So look at everything in Azure. We can hop in and we can search for the thing we want to create, find IoT Hub. We can new one up, and again, it doesn't take very long.
Right.
Usual deal, we're going to pick a resource group, we're going to pick a pricing tier, we can pick a location, all those standard things we do with Azure we've mentioned before as well.
Yeah, it's really a little scary how easy it is to new up just about anything in Azure. New VM, magical machine in the cloud, new network, new subnet, magical VPN in the cloud. So like everything else, it takes about 4 seconds to create something incredibly complicated. So
absolutely, and just show you here it is, IoT Hub. You can new one of those up and off you go. Yeah. Now, I'm going to open up one I've already created. So this is called Excel here. And right away in the overview, we see we have a host name. Right? This is really our endpoint. This is where we're going to send our data. Our devices need to send it somewhere. Well, they can send it to our host.
That's our endpoint, right?
Now, of course, we mentioned security. We're not going to go into a lot of detail, but I want to show you that this is designed to manage devices. So we go down to our Device Explorer. And here we see a list of devices we've already created, and we can, of course, add more devices. I'll do it through the portal. There's a number of options. We can do it programmatically. We can script it.
Right, just like anything in Azure, we could of course just pull open PowerShell, and if our PowerShell foo is on point and our Azure scripting foo is on point, then we'll be able to just script and do everything there. I do tend to like to use the portal because my PowerShell and Azure CLI foo is not on point.
Absolutely. I love the portal. I love doing it programmatically.
Right.
And again, if you're provisioning a lot of devices, you might use the API and provision programmatically, especially if you don't want to do it, be out in the field, wire these devices by hand.
Right. If you're doing it as part of your process, if you know you have to be standing up new things as part of an ongoing process, then obviously, doing it programmatically makes a lot of sense. But being able to point and click is obviously pretty easy.
And pretty fantastic here. I might as well just even save this here. So I put in Adrian's Raspberry Pi, and hit save. I'm going to leave the default. So this is going to generate a symmetric key. Of course, I can actually input one here, but I'm going to.
The other thing he could also do is choose to use public-private key authentication as well. So he could click the X509 and upload a certificate, exactly. So we could choose to do that as well. Yeah. But in this case, we'll stick with the key mechanism.
And you saw it really fast, just that quick. And when we look at any of these devices, so I'm going to look at one. I'll look at my Android Things device here. Notice that we jump in and we have a device ID. That's, of course, just how we name the device. And then we see our primary and secondary keys. And these are just symmetric keys, really for our encryption, for our communication. Right. And I'm going to grab one of these, grab the key.
You can think of it as our device's password. So we set up a device ID, that's the username, and the key is the password. Now, it's not a person's username and password, it's a device's username and password. But obviously, then the key should be treated privately the same way a password isn't. This does bring up kind of an interesting point, which is that key, and therefore the data in your hub that you're analyzing, is only as secure as this device. So my device isn't very secure right now. You can see anyone can walk up to it and they can access the memory chip. So it's not very secure right now at all. However, obviously there are ways to handle that. But that's a different story. But remember, your data in the cloud is only as secure as the devices that are able to send data to it. So if that key is compromised, anyone can pretend to be this device.
Yeah, absolutely. We could do an entire talk on IoT security. So for now, we're going to do this the more direct way. So I'm going to bring in my device ID, my key, and my endpoint, my IoT Hub URI, and this now in our source code.
Perfect.
And really what I'll show you here is that we're going to, I'm going to call a send message. And so it's send data in my shared code. And really, the main important part is over here. Let's open up my device to cloud class. So this is my shared code. Let's jumping to the interesting point. So we pass in our device ID, our device key, and our endpoint, our IoT Hub. And here we saw on the slide, device client.create. And again, we're just passing in all of those details. And the important part here is we now have a device client object that we can use to send data. Now, there's a little bit of specific here about getting sensor data, but what I want to show you is to send the message, all we do is use that object, the device client object.
Exactly, just like we saw on the slide.
Yeah, and call send event async, and we're sending a string. Now, there's something interesting here in that, yeah, it's just a string, but of course, there's many encoding schemes we can use to put data into our string.
Of course, we have JSON, obviously being a common choice because JSON is awesome. I mean, JSON is awesome.
I think they're both pretty awesome. But absolutely, so we're going to use JSON convert here. We're going to serialize the object into a string, do our encoding, create our message, and fire it off to IoT Hub. Because we defined that endpoint, that URI, the message is off.
Excellent. Now we're done.
Yeah, and we've got a little bit of authentication there. Of course, we've got the keys are matching, and yeah, so that data is off to the cloud. And if we go back to our portal, we go to our overview for IoT Hub. Let me just, here we go. We can see what messages come in. We can see that we received 900 messages today here. And notice again, this gives a sense of scale. This is the number of messages per day, and we're on our low price tier. I've got my S1 standard pricing tier.
We're on the very basic pricing tier.
400,000 messages a day. So again, high volume.
Of course, it goes up vastly from there.
Right. So this receives data, and actually there's a queue in the background. So it will store the data, but it's really meant for you to hand off to something else in Azure, so we can then do.
It's a temporary shelf. It's just a little holding tank, and so you have what, 1 to 7 days.
Yeah, exactly.
You can configure it.
So let's go back and do something with our data. And to that, we're going to do a bit of function app programming. So we're going to use a serverless compute, a function app.
And the first time function apps were explained to me was actually by you, and I said, what? What? Wait, this doesn't make any sense. You're just giving me magic. And I know this sounds like a sales pitch, but I want you guys to realize how blown away I was, because he's going to write a method. He's going to have a single method, and it's going to have all of the data he needs, and he's going to have access to exactly what he needs to create the output, to output it, and just do it all within the single method, or whatever other methods he calls from it. But there's no class, there's no project, there's no server to deploy the project or class to. It's just write a method and ta-da. And
absolutely,
pretty blown away. All the NuGet packages that you needed.
Yeah. Let's have a look.
Amazing.
So this part here, yeah, I love function app, serverless compute. Okay, let's talk about that. So we're going to go from IoT Hub. We're going to process our data, our messages, with our function app, and then we're going to put it somewhere. So we're going to put it in table storage, and I'm going to pass it over to you for table storage. But let's talk just a little bit about function app. So I said it already. It's serverless compute. So we love cloud. We love Azure. The most basic thing was running a virtual machine in Azure, which is still valid today. I mean, you did it today. You've got a VM running Linux. And VMs are fantastic because we're not worrying about the hardware, right? It's less management. We're just deploying the OS and the software.
But we still worry about the OS, the software that's installed, the stack.
Right. We're still patching and versioning and all that kind of stuff. And so there's the next level of abstraction where we just run an application platform. And we're not worried about the OS anymore. We're just worried about the executing platform. And this is the next level of abstraction where we're no longer just deploying a project in code. We literally just write the function that we need to do the work. Azure takes care about the executing platform, the runtime environment, any versioning, OSs, all that kind of stuff is abstracted away from us. We just write a function, and it just calls run and does some work for us.
So it's kind of like static void main. It's almost like a console app, but it has access to well, I see your event data coming in there. So
yeah, absolutely. So this is a really good indication here. So we've got some input data on our function app, and again, we can do some processing, and you notice that it is C#. So I think the best thing to do is go over the portal, but I wanted to show you a couple of core concepts first, and maybe talk about table storage.
Excellent.
And then show you this to you in action. So a couple of cool concepts with function apps. We have something called a trigger, and so as Jason mentioned, we're not worried about all of the infrastructure around it. But by that, we don't really have anything that runs our application, right?
Right.
What calls the run method?
Right. I don't have a user to press a button or to hit enter on my console.
So for function apps, we have a concept of a trigger. And this is something we see in other parts of Azure as well. And it's what you think. It's that button press. It's what's going to kick off our function app.
Make the function run.
Now, great news for us. IoT Hub has an Event Hub style endpoint that we can connect to our function app. And the great thing is they're really designed to connect together. So every time we receive a message in IoT Hub, we can have it trigger our function.
And so run our function for that particular message.
And the great thing about triggers is all the triggers pass in data. And so in that case, this Event Hub trigger is going to pass in the message that we receive by IoT Hub. exactly what we want.
Excellent.
But of course, there's other kinds of triggers. So you can get a scheduled trigger. Of course, you can just have it go off at a certain time, certain period. There's an HTTP trigger, and actually, you made a really good point yesterday. This is the kind of the catch-all, right?
Right, because if you don't know what else to do to get your app to trigger, I mean, everything else that you have, every other integration point you have in Azure or anywhere else has some access to HTTP, generally speaking.
Yeah.
So I can always figure out a way to trigger my function app by just hitting that HTTP endpoint.
Right.
It's very general purpose.
From a mobile app, any kind of client, and really other parts of Azure that might not have the correct trigger wired up.
Yeah.
HTTP requests, love it.
Perfect.
And then we also have what we call bindings. And bindings really let us interact with other pieces in Azure. And typically the bindings refer to storage. So an important concept of serverless compute and function apps is that they're stateless. So they're going to run. You're going to pass in some data. It's going to run the method. It's going to do its logic. And then it's going to power down. And so two important concepts. The function apps by default are only going to be alive when they're needed, when they're triggered. They power up. They do their work, then they power down again, and they're not going to retain state. So if you need to retain state, whether that's stateful within your function, or you just want to save off data, you're going to need to connect to, well, some storage. And that's where the bindings come in. The bindings allow us to connect to other things in Azure, generally storage. And
grab access to some other thing in Azure. And then it's being passed to my run method, it appears, right? So my run method is just getting access to my table or my SQL server or my queue or whatever it is. It just gets passed in, and I just use that API.
Absolutely,
because it's passed in as a parameter.
Again, because we don't have state. There's not a class level variable. We're going to get passed in the run method as a parameter, and off we go.
Super cool.
And so what we want to do, of course, is we're going to save our data. We want to have historical data from our IoT devices, which would make a lot of sense, especially for devices in the field. And for that, we're going to need some sort of storage.
Right.
What kind of storage should we use?
Well, we like table storage for this. And table storage may be a little bit unusual to some people, or its way of use may be a little bit unusual to most .NET developers.
Well, and it's a little bit new, really, compared to something like a full relational database.
Well, certainly it's new compared to that, although the concepts behind table storage have been around for well over a decade, but yeah, it is certainly newer compared to, say, relational database management systems like SQL Server, and it's used differently. So table storage is this idea of well, it's a lot less expensive, which means I can store an insane amount of data relatively cheaply. It actually uses your same Azure credits along with blob storage and file storage. Compare that to the more expensive storage options like SQL Server or Redis, and you'll see that table storage is a very, very kind of low-level, just easy way to access simple data.
Right, and I think what you're saying here is really important. You're saying table storage, and you're comparing it to SQL Server. Right, with SQL, we're powering up a full server, whereas table storage is just
right.
storage.
We're talking about transactions and atomicity, and we're talking about a lot of things that go beyond just simple storage. So table storage is really meant to be very simple, and you can simplify your data by structuring it in a certain way, right? So that's the part that you see a lot of developers have a hard time with is we're going to simplify our data. We're going to flatten our data. We're going to duplicate our data a lot. Instead of having relational tables or callouts to another table through a foreign key, we're just going to flatten that data. We're going to put all the information for a given record on that row. And then the other interesting thing about table storage is you're going to have exactly two indexes. They're not exactly indexes, but we'll treat them that way. And they're always called partition key and row key. Now, partition is interesting because this actually refers to physically kind of how we group our data. And the interesting thing about that is now I know that Azure has some abstractions around physical storage, so I'm not going to say it's actually always on the same physical hard drive, but you can almost think of it that way, as if the partitions all live together on a single physical device. And then within that, the row key is the index within that partition.
Okay, so with our IoT devices, what might be a good use of the partition key?
Well, it really depends. The idea is just to get uniqueness between partition and row. So partition
maybe the device
and row
ID.
key. Absolutely, that would work. It really depends on your situation. You might use device ID That might be enough uniqueness for, say, a device table that only has one record per device. However, if you're getting a lot of records per device, you might need to concatenate that with more information. And this is another one of those parts that can really bother a traditional relational database developer, is since we only have 2 keys and they're always strings, it's actually considered a acceptable and correct pattern to structure your key by kind of mashing together multiple pieces of information. As long as you can reconstruct that in order to do an efficient filter, an efficient query later, and by the way, as long as you're only querying on partition key and row key, it is super duper fast no matter how much data you have in there, because again, the partitions kind of break things off into a separate universe for you, a separate physical location.
Okay, and I feel like speed is probably important here. We're talking about a lot of messages from IoT Hub.
Right, speed at scale is critical. What we trade off is complexity. We have only a very, very simple set to work with. 2 indexes, they're string based, and that's all the uniqueness we get. We try to search on other things. It's very, very inefficient. If we search on any of those other columns, and we can have many other columns, in fact, often you'll see, because we flatten our data, you'll see hundreds of other columns. But we won't search on those. We won't try to filter on those, because everything has to be read up into memory in order to filter on that data.
So it just requires a little bit of creativity, a little bit of planning on how we use the partition key and the row key, and potentially even additional tables then to access certain types of data if
Absolutely,
we need to.
and I think the biggest thing is to just kind of break out of some preconceived mindsets that we have based on how we've used relational databases. Relational databases are still my absolute favorite way to store data, don't get me wrong.
Very, very flexible, very fast.
Very robust, very flexible, very fast, and they do all of the things that I need. Can SQL Server store terabytes of data? Absolutely. Can it also provide atomic transactions? Absolutely. Can it also give me a transaction across multiple reads and multiple writes? Right? It can do all these things. But there's a cost both in terms of actual dollars, and there's a cost in terms of compute trade-offs. Table storage gives us all of a small percentage of that at a small percentage of the cost.
Absolutely. So it's really picking the right tool for the right job. And in this case, this is a great option for us.
Right. This does everything we need.
Yeah, but it might not be the only solution. You could use an alternate alternate storage mechanism that is better suited to your solution.
Absolutely.
Let's head over to the portal and see our table storage and our function app. So back to the portal, and I won't walk you through this every time, but again, all these things are searchable. Please go into Azure, fire them up. Most things spin up very quickly. Hopefully you've created services in Azure before. I will show you for table storage. It actually comes under, I think the search comes up.
Why don't you go ahead and make sure you've duplicated or mirrored your monitor?
Oh, we're not mirroring? Absolutely. Let's get that going. Sometimes my device drops out there. Thank you.
We mirror it, then everybody gets to see, which is probably more fun for a presentation. I mean, Adrian could just go ahead and do his own thing.
I'm glad you're watching the monitor here. Let's get this over to duplicate. Excellent, yes. The resolution change should have been a tip-off there. Perfect. All right, back to the portal. Excellent. So table storage, if I search for this, actually comes up under storage account. And you said something that I thought was really insightful here, that kind of little light bulb off my head here. Because we see storage account has blob and file and table and queue storage. And why is that?
Well, again, table storage is pretty simple. It's a pretty simple structure, and so we really just bill for it the same way we bill for blob storage, the same way we bill for the very, very simple stuff. It's basically we're renting you disk space when you use table storage, when you use blob storage. And you'll notice again the other services like Hadoop and Redis and SQL Server, right? Those have different levels. They are providing services on top of disk space, and so there's a different price structure associated with that.
So storage is kind of the keyword here.
Right, table storage is simple disk space, basically. It's simple storage.
Okay, and function app, same thing. We go in, we search function app, new it up, and off we go. So let's take a look at the function app. I think it's a lot of fun.
I love this.
Yeah, I know. I'm really excited. I think this is something I'm going to be using quite a bit in the future. So we new up a function app, and then within the function app, we host functions. Makes sense. Let me show you a function right away. I think that helps give you a little bit of insight as to what it does. So it jumps in. I've got this run.csx. And right away, we look on line 6. We see our run method. And notice we hear our IoT Hub message coming in. And then we got our reference to our tables coming in. So all those things we needed, we talked about in the slides.
Yeah, so we're going to need to see how that happened because it looks magical right now.
It's magical. It's all here. Yeah. No. And the great thing is
everything I need is right there for me.
We've got some really fantastic UI to manage this. So if I go over to integrate, here we see our triggers and our bindings, our inputs and outputs.
So what I want is I have this. I want to get some data from IoT Hub, and I want to do some processing and then store it somewhere. And I just saw that you have a function that just has the data that we need to use and the output that we want. It's already just there and ready.
It's pretty fantastic. So if I go to IoT Hub, and we go down to our endpoints, and click on Events. And this actually presents then the Event Hub compatible endpoint. And all we do is define a consumer group, and it's really just a label. And so here I've got my my function app. Again, not a creative name, but nice and direct. This is my consumer group for my function app. This allows it to communicate with our IoT Hub.
Right, excellent.
And with this set up, and again, literally just write them in. There's not much going on here in terms of defining this. I can delete it, but I can make new ones. So it's just really my label for my connection here.
Yeah, great.
And we'll go back to our function app. And I can wire up to that Event Hub compatible endpoint. And I just make sure I use my consumer group here. And if I scroll down, there it is. My consumer group is called function app. And I wire to my Event Hub, my IoT Hub, and off I go. And now,
and so through your Event Hub interface, you've basically said, I want to kick something off every time we get a message here, because that was configured as part of the IoT Hub. And then in the function app, you're saying, okay, yep, I'm the thing that you should kick off by making the trigger that points to it.
And I think what's important to understand here is I'm going to show you a little bit more under the hood, but really deeper into the hood, Azure, the parts of Azure are meant to communicate with each other. This is the value of using something like Azure, where it has so many things. They're meant to integrate, they're designed to work together, and this is a great example of this.
Find a Lego piece that fits what you're trying to do.
But this wasn't two random pieces of the box. It's lots of these things are meant to connect this way, and they're standard connections, and there's lots of plumbing and wiring under the hood for us.
Yeah,
Pretty fantastic. Now again, we see our inputs and outputs. So if I wanted to restore state, I might have an input for some storage here.
Okay.
For us, we're just going to write data out to the output table here. So notice I just have my Azure table storage, and it's the exact same
So this is why we also had our tables being passed in, is because we're configuring it saying, give us these.
Yeah, and you can see here there's actually a lot of options for our output. We can actually go back to another Event Hub. We could even trigger another function app. But again, we're noticing Event Hubs, right? This is a standard trigger mechanism, standard communication mechanism in Azure. It's pretty fantastic. And we see our other storage types. We've got queue and blob. But again, lots of fun things here. I don't want to overwhelm. Just want to show you that they've made it really easy to wire things up. And again, pretty fantastic. Now, this all looks sort of magical. I just click on some things and off it goes. But we can go to the advanced editor. And this gives us a little bit more insight of what's going on under the hood here. This is just creating our bindings. And here we see a type, an Event Hub trigger, and a name, IoT Hub message. That's our name. That was the string that came in our run method. And again, a little bit defining, here's our consumer group, our function app, and so all of this is defined in JSON. Azure can process this and really connect the dots for us. The exact same thing for our table outputs. Again, we have a type of table, we give it a name data table, we've got a second table that's our status table. And again, this actually, I won't go too far into it because we've got so much to cover, but this goes back to architecting our table strategy so we can quickly get the information we need without doing a full query, for example. So we're just updating our status when we get a message from our device. And that's something that can also be done directly from IoT Hub as well. So lots going on, but if we go back now to our function app, notice our run method here.
Now I have to interrupt you one more time because, all right, I've got it. You've got your message coming in, and I see the tables for outputs, and you've explained that, and I got that. But there's one more piece of magic you're using still that isn't being passed in. You're using NuGet, or you're using JSON.net here.
Absolutely. So let's look at that code really fast, and then I'm going to jump over to that because that's a really powerful thing. And this is
because it's amazing that from this little main method here, this little run method, you can access that tool.
Absolutely. So we are in C#, and this is a C# script, a CSX file, which again means we have the power of C# and .NET. So notice our run method is calling a couple of functions, a couple of methods here. We've got update data table, update status table. Now remember, we did some JSON encoding of our data back on the client side. Now we have a JSON encoded string message coming in. So we're going to pull it apart using JSON.NET. And here we see on line 18 our J object, and we're parsing and pulling out our acceleration data. And so, of course, JSON.NET we know is deployed as a NuGet package. So if I go to view files here, notice we have a project.json. This should be familiar to a lot of .NET developers.
It's just like what I do have in my SLNs, my solutions.
Absolutely, right? We wire up our dependencies. And in this case, we define a dependency for Newtonsoft JSON, and I happen to pick version 6. Of course, we could update the latest version.
And so when we run my function app, it goes to the internet, pulls down the NuGet package, and uses that to run the code that I've written in my function app.
Absolutely. So when the function gets triggered, the function spins up, it pulls in the dependencies, and runs your code. Now, presumably under the hood, I don't know all the magic that the Azure team pulls off. There's probably some caching involved. But it's worth keeping in mind that our function app has to be brought up. And so adding a lot of dependencies may impact performance.
All right. But still, this is ridiculous. I mean, so you guys thought I was using some hyperbole. If you haven't seen function apps before, then you've got to be as amazed as I was. This stuff is crazy. Like we don't even have a project. We're not publishing it with its NuGet packages or anything like that. We're just writing some code right in the portal. It's executable. You told me it doesn't even have to be C#.
No, absolutely great point. So and I can run multiple functions in my function app, and I'll just show you quickly here languages. Bash, C#, F#, JavaScript, PHP. Pick the tool that you are familiar with, that you know best, or that's best suited to the task at hand.
Right, we can chain these together. So if I have some heavy-duty math processing, maybe I will write some Python in a function app because that's great for doing some heavy-duty math, and then I'll chain that to a C# script because that's maybe what I'm more familiar with.
Absolutely.
Because I called someone else and asked them to write the Python script for me.
Well, exactly. No, I wrote this the first time in JavaScript to see if we get it working. That's great.
Awesome.
Now I'm going back to C# because that's where my comfort zone is. And there's a lot of templates here as well. They're quick starts, and they've got some wiring here as well to set up the bindings and triggers.
I am kind of curious as to why you would choose to voluntarily do JavaScript.
A little bit of a challenge. So excellent. So again, now quickly, let's go back to our slides. Look at this moving. There's so much cool stuff to cover here. So going back to our architecture and jump right into it. So at this point now, IoT device sends data to IoT Hub. Function app is triggered. And we did this pretty quickly, but actually there's some code in the function app that's writing to our table store using those passed-in values.
Right, we've got it passed in, so it's pretty trivial to just actually write that then to a table.
And so now we've got it in table storage. We want to expose it via a REST endpoint to make a web app.
Right.
And so we're on the second half here of our project, and our web app. Well, okay, we're C# developers. What are we going to host?
ASP.NET in an Azure web app, yes.
Absolutely. And so, of course, this ASP.NET web app is going to be pulling in the data from table storage and then exposing a REST API. We won't go through all the details of our ASP.NET project because I think a lot of you have seen this before, and I think there's some other really great talks today,
we
too.
We actually saw some amazing .NET Conf talks around ASP.NET, so you guys should definitely check those out. But yeah, we won't hit that one too heavily, but it's pretty good stuff. And I do see we have not exactly. Well, we have one question from D Yardy, who I know from my Xamarin University classes. So hello, David. Good to see you on there. I'm assuming if that's some other D and not David, then I apologize. But I'm assuming that's David from Xamarin University classes. And you can't have one of these shirts because it's for employees only. And
I'm not sure these exist anymore.
They actually don't. They're for employees who were employees 2 years ago, actually. And Funkionics noticed that we've given them 6 hours, so you're welcome.
Yeah, and we're having a great time. And
we are. This is fantastic.
Yeah,
Thanks,
we're
guys.
having a ton of fun with this. So yeah, absolutely.
I just had to acknowledge those guys.
And cheers.
Cheers, exactly.
Do you want to show the mobile app a little bit there, the ASP web app?
Let's give them a quick look. You got it open.
Perfect.
And so we've got some other interesting things that actually do go on with that, besides just the REST endpoint hitting table storage, right?
Yeah, absolutely. So I think I'll just show you very quickly. I'm going to show our controller, and it's just an API controller. And so again, to expose a REST endpoints, and a little bit simplistic here, but we've got a connection string to our table storage. And again, a lot of this is automated for us, right, in the Visual Studio tooling. We connect our Azure account, we sign in, and we can get the connection strings. It'll actually add it to our solution for us automatically. Again, Visual Studio, ASP.NET, they're all built to work with Azure.
All of this stuff is, it's all Lego pieces that fit together that have the Lego interface. Therefore, they all plug together doing their own things.
I think I can dig into my web.
We can write a little code inside of our Legos.
And you can see here we've got some of the keys are defined here. I won't go through all the details of it, but they're all nestled away in there. And of course, we have what I want to show you is we have our REST endpoints, right? We've got our get methods here and such. And so now, and we can query per device, and we can query over time, and we can hit this endpoint. And so we saw earlier, Jason, on the presentation, we're sending data from my IoT device. Now I've got, of course, no surprises here. We've got a Xamarin.Forms cross-platform application that can consume this data. Should we fire it up?
Yeah, please, let's.
All right, so this says start project. I do it in UWP just for the deployment performance. But of course, it does work on iOS and Android.
Sounds like a great plan to me. It fires up faster just for our demos because we're running from the IDE, so it fires up faster. But in terms of actual performance of your apps will perform just as well on all the platforms.
Oh, absolutely. And so here right away we see we've got some devices, and so this is actually querying our REST API.
It is, so, and I will warn you that if you hit Jason's Raspberry Pi 3, it's going to take a long time to load all the data because we've been standing here for two full presentations uploading data.
Yeah, I think my call right now I think is over time, not over number of data points. So I think it's a little bit piggy, right? So let's do one of the other devices, one of our test devices, our Android Things device.
Excellent.
And so hopefully it's just going to query the REST endpoint and pull in some data. Yeah, we'll give this a moment.
Get a little Jeopardy music. I am actually spamming the endpoint. We are on the with my device right here, the one that you guys see sitting between us on the table here, is actually currently uploading data and has been.
Oh, good.
For the entire duration of our last few sessions. So this thing is chugging away, and we're actually going to see the data that we're getting shortly, I think.
Maybe.
All right, I'll tell you what. Well,
there we go.
Right.
I'm just impatient. Let's pull it back up. Sorry. Give me one moment. I think we're pulling a lot of data down. That's
yeah, no problem.
Yep. So we'll give it a moment. But while this is loading a second time,
should we see the real-time visualization again? That's always fun as well.
Absolutely.
All right,
absolutely.
So over here, I actually have the real-time data coming from our device right here. And so you guys can see that the box on the screen is moving. Well, this box is moving because I'm moving. Some of you watched our previous session and you already know this. But this box is moving on screen because I'm moving this device. That data from the device is being processed partially on the device and partially on Azure because we move the data up to Azure. Azure does a little bit of processing in that function app, and then we actually store it in our table, which is what we're about to show. Now, it turns out that while IoT Hub and table storage are great, IoT Hub really is the one great for volume, great for security. There are some limitations, it being a queue-based system. So it's a queue-based system means it's not quite real time. And so for this visualization right here that you guys see on screen, where I can make my little cube dance around, for that we actually do take a different route. We actually kind of Y our branch, our data. And so part of our data actually goes, instead of going through our function app and table storage chain, it hits our ASP.NET web app directly with SignalR. So we also ping our ASP.NET web app that has SignalR set up, and then SignalR will rebroadcast that message to any interested clients.
Okay, so you're basically bypassing all the cool stuff in Azure. Well, why did we do all that work?
Well, we did all that work because obviously we have historical reporting here. Everything with SignalR is ephemeral. That data gets broadcast out, it's real time. We can have real-time clients see that data, but it's not being processed or stored.
Right.
It's gone as soon as the clients receive it. So it's ephemeral, it's not reliable. So we're handling two different situations in the way that's most appropriate.
Right, and so that full pipeline again means historical data. It means that we can query per device, and it means that we can expose it in several different ways. So it's very common for a business to have a website to actually do visualization. We didn't show that today, but it'd be very like do some graphing and charting and data analysis right there on the website, as well as consume it from mobile clients. So that web app gives you a lot of flexibility.
Exactly, we can do a lot of different things, and just like the web app has a lot of flexibility, again, so does Azure. So we're going to handle certain things in different ways, depending on what our needs are. So we had two distinct needs. We need to do some data processing and some analysis on our historical data. We want to see trend lines, and we want to also maybe apply some machine learning to this data. However, we also wanted to see a real-time visualization so we could see what's going on right now. Two different requirements, we handled with 2 different branches.
Fantastic.
So let's actually see how we set up Signal R. So we already had our web app. And so since we already had this web app, all I did is add the Signal R NuGet package to my ASP.NET website, by the way. Added our ASP.NET NuGet package, and then added this app map Signal R to my startup class. So in other words, as soon as the app domain loads for ASP.NET for this project, it's going to say, all right, map Signal R. All this does is go looking for Signal R hubs and register those with our routing engine, with our ASP.NET routing engine. So if you try to access the /Signal R endpoint, it's going to find our hub. And
this responds to requests, though, so it's not running continuously. It's waiting for that request.
That's right. This is an endpoint. So this is an endpoint on ASP.NET. So it's waiting for something to hit it. And so when something hits it, what it does then is it adds it to this. Well, it doesn't even really add it to anything, to be perfectly honest, because it immediately just looks for anyone who's interested in hearing this message. So we hit that hub. The hub says, is anyone listening? And I actually have our apps, our mobile apps and our UWP app set up to register themselves to listen to only specific devices. For instance, in your app, when you click on in the list view on one of those named devices,
right,
we have the ability to do that same visualization we just saw. And so it's going to show the device that you clicked on. Now, the version that you guys have seen on my laptop just is hard-coded to that machine sitting next to me. But we register to listen on a certain device. So our clients hit this endpoint here, say listen on device. And so once those client apps listen on for that device, then when that device pings our startup, our Signal R hub here, then, well, what we have is our device data received. That's actually where the device pings us, hits our hub, is device data received. And then you can see we actually go and we broadcast for a given device. Actually, we have our send for a given device, our clients.group. So this group says, all right, I'm going to broadcast anyone listening for this device. Now, I do this every time. Each of my devices, when it sends data, is going to ping Signal R, and we're going to say clients group device, and we're sending device data. Now, if there's nobody in that group, in other words, nobody's listening for this device, that data is thrown away, gone forever. Once again, it's ephemeral. Even if we do send it to some client, the client just displays it real time and then throws it away. So this is all just for real time. It's not storage. It's not reliable. It's not guaranteed in any way, shape, or form.
But incredibly powerful that we can potentially, in near real time, get status information or visualizations from our devices in the field.
Exactly. For our real-time needs, this is pretty amazing. It's just not appropriate for our analytics or reporting or long-term storage. For that, we have, it looks like your app is now
I think
showing.
we're up and running, so we can switch back to my machine here.
That's great.
I think my development machine is getting a little tired. But here's our Xamarin.Forms client, and this is running on UWP, and again, for simplicity of deployment. And again, all live web data, and what I love about this stuff is we can consume the data in various ways. We've got a list view showing our acceleration data. We've got a graph. This is pulled in as a third-party NuGet package. Makes this really easy to write, fairly interesting and responsive bits of UI.
Yeah, it's amazing.
Now I'm gonna try the real time, and I'm gonna have to let the cat out of the bag here. Says I'm thinking it's a little bit delicate at the moment, so I'm gonna hit the real time. And this actually is connected, I believe, to, is this connected to your device right now, or is this the?
I'm not sure. We might have left that one on the sample data, so it might just be running. That one might be running. It looks like it is because we're not moving the device.
Perfect.
We've already seen the live real-time
But of course,
demo,
yes.
So we've seen it on mine. We don't need to prove it.
All right, perfect.
Excellent.
And again, the great thing is all of this code, really everything except for the function app, which of course is tucked away in Azure. But actually, I'll pull it down into GitHub. But all the code we're demoing today is going to all be it's all on our GitHub. We'll show you that link in just a moment.
Yeah, perfect. And actually, you didn't even mention about function apps. I believe we now do have support in Visual Studio. So if you don't particularly love the idea of doing your development in the portal and relying on that NuGet package being pulled down every time, then you can actually develop now in Visual Studio your function apps and compile them so that your NuGet package is there with it all the time, and so that the startup speed, that startup cost that you talked about, if you had a lot of NuGet packages, so you don't have to pay that cost.
Absolutely. So really, really quite powerful. Right? Again, exactly pre-compiled, hopefully faster load of time. And it leaves you open to other things too, like developing locally and even deploying through VSTS as well. So again, really integrating all those amazing tools we have. It's fantastic technology. I can't wait to write more functions.
Yeah, I mean, so guys, we've seen, what, like 5 or 6 Azure tools today, and we've seen it do some amazing things. Like I said, there's actually just thousands and thousands. I don't know if that's literally true, but there is so many Azure
It definitely
tools.
feels like it sometimes.
I think it may actually be true, to be perfectly honest.
I think we're on our way.
Right.
Yeah.
There are a ton of Azure tools, and all of them are built to work together, to fit together nicely. So it's a lot of fun experimenting with them and learning how we can build amazing tools.
Yeah.
Just the Function app alone, how we would have had to have handled that before, standing up our own separate server, running some code that was listening on a queue in a loop. I mean, man, that's a lot of work compared to the magic that he just pulled off.
Well,
so,
and what was great here is, I mean, we didn't new up all these pieces, but really the IoT Hub didn't require much more work than what you saw today. The Function app, writing a bit of C# code. Table storage, we knew it up. We write to our Function app. So a lot of this can actually be deployed very quickly. And if you've got ASP.NET Web skills, that REST endpoint goes pretty fast as well.
It's pretty crazy.
So what we really wanted to get across today is that, well, one, there's a lot of fun, amazing, cool technologies you can play with in Azure, but also give some insights as to why we chose these technologies and kind of how they fit with each other, and also within Xamarin as well. We had a lot of fun. And the last thing I want to say here is, I think it's clear, but I love that we've got Xamarin on both ends.
Right,
here.
we've got Xamarin on both ends, feeding Azure, Azure having an incredibly cool pipeline working with the data, and then Xamarin consuming the data. Yeah,
Absolutely.
really cool. Xamarin and Azure.
Right,
Love
just
it.
fantastic. And the other message is Xamarin's more than just phones, right? It's more than just mobile.
It is your rich client tool of choice. Yeah, it's a rich client. So whether it's a IoT type device, whether it is a mobile device, whether it's a desktop, it's there.
Yeah, fantastic. Well, I had a great time.
Me too. It turns out this is actually our last .NET Conf session. Wow.
And I think this is the end of day for .NET Conf too.
I think it is. So we did it. All of us, not just Adrian and I, but the entire .NET Conf. Pulled it off. This is pretty fun.
Yeah, I can't wait to go off and watch some of those.
I know
sessions
some
we
of the
missed.
other sessions that we weren't able to watch. So this is an amazing conference. So what we did manage to catch was amazing, and I think we didn't do too bad.
I had a great time here.
Excellent.
So if you're hungry for more, I've got a number of links here. Of course, again, our source code, ak.ms/netconfxamu. Source code for, it's all the same repo for all of our sessions. So you get the IoT code, the mobile client, even the web API, it's all in there. Lots of great fun stuff. A bunch of documentation. Obviously, Bing is your friend. You can search for these kind of things. IoT Hub, Function apps. There's really, really great, fantastic samples out there. Can get you up and running. And to go out there, have a great time, and build amazing things in the cloud.
Yeah, and if you're wondering where you can learn more about Azure or Xamarin,
that's a good
maybe university.xamarin.com would be a good destination for you. Remember, there is a ton of free content there, and then there's the option to go into live classes where you can interact with me and my fellow instructors, and we have a lot of fun teaching you guys how to do really cool stuff like we've done today.
Fantastic. Yeah, definitely check it out, university.xamarin.com.
All right, guys, thank you very much. As we said, it's been an absolute blast doing all these .NET Conf sessions with you. Look forward to doing it again.
Thank you very much.
Bye for now.
Take care.